Hi, my name is Marco Cantu and I'm the Delphi Product Manager at Embarcadero Technologies. Welcome to this Code Rage session focused on the Delphi language evolution. In this session, we'll focus on some advanced and surprising Delphi language features, just a couple of features that you might have missed or not used to the full power. I'll focus on recent additions to the Delphi language and specifically what's new in Delphi in the 10.3 real release. And also I'll hint at what's coming in the future. Before we get into the details, let me provide a roundup of the core ideas around the Delphi language today. It's a very popular language, alive and kicking. It still shows in most of the statistics and usage data. We know that there are a lot of applications being built in all fields and all areas. The language has a great heritage dating back to Borland Turbo Pascal and continuously evolve with modern features. The difference compared to the past is that we're now shipping 8 Object Pascal compilers, 4 based on the classic compiler and 4 that are based on the LLVM compiler infrastructure for Windows, Mac OS, Android, Linux, and 32-bit and 64-bit versions. Now, if I had to provide a definition of the Delphi language, I would just quote myself: power and simplicity, expressiveness and readability, great for learning and for professional development alike. These are some of the traits of today's Object Pascal. A tool for all trades with compiler and development tools, embracing the mobile era, a language ready for the future but with solid roots in the past. 3 days for the Delphi language history. 83 was when Turbo Pascal was released. 95, Delphi became Delphi. And by the way, this is also the year many other programming languages were released, including Java, JavaScript, PHP, and Ruby. So when people hint to, oh, Delphi is old, JavaScript is new, it's kind of a misnomer because they were invented and they were introduced the same exact year. Now, 2009 is another relevant day because it's where Object Pascal was transformed in what we call modern Object Pascal with generics, anonymous methods, reflection, and attributes. And now we are seeing new things coming to the language like inline variables and type inference. What's important about modern Object Pascal is that it's not just additional features to the language, but additional programming models. So it implies going beyond traditional object-oriented programming with generic types, with anonymous methods, with extended RTTI, with the ability to write highly dynamic code, and so forth. So again, not just an extension to the paradigm, but also augmenting the model with alternative approaches. So let me start looking at some surprising code, and I just want to touch on a couple of areas. One is around generics, and I'm going to focus on 2 demos, and then I'll focus on interfaces and interface weak references. For generics, as you know, they offer the ability to write parameterized types, which is very common for collections, but generics are not just for collections. Here I'm going to show you a first demo that uses generic methods in plain classes. This is a largely underused feature of the language. It's extremely powerful, and it's also the first case of type inference, something we'll talk more about in reference to new inline variables. The second demo I'm going to show you is a smart pointer example. One of the reasons is because it's interesting. The second reason is because I'm actually going to leverage it in a later demo. In this demo, I've created a class, which is not a generic class. It's a regular class, but it has a generic method with the parameter type based on the generic type declared. Now, what you can do is call the method indicating the type and then passing a matching parameter, like in these first 2 cases. But as I was mentioning, you can also use type inference and basically infer the type of the generic T from the parameter being passed. So in this case, a string, and in this case, char. Or a button, if that's what you're passing as parameter. Now, in some cases, you might not want to use the type specifically passed of the object specifically passed as parameter, or of the variable or constant passed as parameter, but you might want to cast it to a compatible type. In this case, I want to have a T object, although I'm passing T button. So you can force the mismatch as long as the types are compatible. Now let's run this application and see what happens. What this withParam function does is return the type of T and display it. So again, let's see what happens here. I'm running the application, and it shows string for the first string, integer, string, char, T button, and T object. Now, what you cannot do is mix the types. So having a mismatch, in these cases, what you would get is a compiler error, that these two are not compatible, or these two, or these two. So you have to have a consistent usage of the parameter and the type declared. But again, nice thing, you can use type inference, which is something was introduced in this feature for the first time, and now it's been extended to inline variables, as we'll see in a bit. The second demo I want to show is a demo of Smart Pointer. It's an old demo that I've already shown a few times, but it's functional because I need to use it later for a different demo. So what is a Smart Pointer? The idea is to have an ability to track the memory of an object, of a local variable, and make sure that the object is destroyed when it goes out of scope. Now, if you write this code, this is a memory leak. We want to write something like this. We're getting a string list. We assign it to a Smart Pointer. That's one way of writing the code. And with that, you don't have a memory leak anymore, because the Smart Pointer takes care of freeing the string list. Smart Pointer is actually a generic record, and in that way is managed. And inside the generic record, since I need to have a destructor call, which the records don't have for now, they will have it in the future, what I do, I create an internal interface with this private nested type. And so when the record gets destroyed, goes out of scope, the interface within the record, which is managed, gets destroyed, and I can actually free the object that the Smart Pointer refers to. Now, the code is a bit convoluted. I don't want to get to all of the details. You can refer to the demo. So, different ways of using the Smart Pointer. One is creating the object and passing it to the Smart Pointer, assigning to it through an implicit conversion, or you can just create the Smart Pointer and assign an object to it. The drawback is then having used the syntax to refer to the Smart Pointer, or having to cast the Smart Pointer, which is equally, it's not that smooth after all. And the other thing you can do is explicit create. So this is a record, this gets created automatically, and there is an implicit constructor to create that would create an internal string list, because the type is passed as parameter. So the Smart Pointer record knows the type and can do a t.create and implicitly create the Smart Pointer. Again, the syntax is a bit weird, but this is what we can achieve for now. If I use the first approach, I would have a leak because I didn't free the memory. If I use any of the other approaches through the Smart Pointer, I don't have an explicit call to free the string list, but the object, the memory remains clean. The other existing feature that I want to mention is the use of weak references for interfaces. That's something that's been added to all platforms since Berlin. And the idea is that a weak reference is a reference that's managed but doesn't add to the reference count. And it can help with reference cycles and other scenarios. Now, there is also the ability to have an unsafe interface reference. That's just a pointer. It's completely unmanaged and will be up to you to know if it's actually referring to an existing object or not. The weak reference advantage is that once the object the weak reference refers to is destroyed, the weak reference is actually set to nil, which is the specific behavior of weak references. So here I have a simple example of an interface. The interface has a method to add a reference to another object of another interface of the same type. And what it does in the implementation is that it has an internal private reference to the interface, and when you call the add object ref, it would just save it. Okay, so this is the sample code. You have an object you created, you have a second object you created, then you create two cross references, and at this point the reference count remains high and you have memory leak if you press the button 1. Okay. Now, if I change the code to use a weak reference, notice what happens here. The do something returns the current reference count, self.ref count. So let's run it with the weak reference now in the implementation. You notice the reference count remains 1 because the additional reference does not increase reference count. And when the program is completed, there is no memory leak because these references get properly managed. So that's one thing that's important, the ability to have weak reference for interfaces on all platforms, regardless if they use Arc or not. The other possibility is having an unsafe reference. Now, the problem with the unsafe reference that, again, you'd have a leak if you don't free the object somehow, because this is completely unmanaged. It's just a pointer. There's no reference count, there's no add ref, there's no release, there's no automatic operation done on the object. So by design, if I use this method, reference count is 0 because never increased, but never decreased, so we have a leak. With that, let me move to the meat of this session, which is the new features in the language in Delphi 10.3 and also what's coming along. So the first feature is inline variable declaration. That's the ability of having a variable declared inline within any portion of your code, and also declare multiple variables at the same time in the same line, or, because the two are not compatible, declare and initialize a variable. And the same works for inline constants beside inline variables. Now, as we'll see in some extent, you can use type inference, so you can avoid the type declaration and let the value you are assigning determine the type. And in that case, notice that if you're using a small type, integer becomes the default for small numeric values. There is another scenario that's interesting, which is the ability to use inline vars also for the loop counter of for in and regular for loops. So here is a simple code snippet showing the constructs in place. This is a traditional way of writing a local variable before the block. And this is similar code with the new inline variable. So now we're declaring two variables, assigning them, and using them in the code. Now, what you can also do is have a single line that where you declare and initialize the variable with a value. Of course, you can have multiple of these lines, each one declaring the variable. Notice that the advantage in this case is that there is never a place where you have a variable that hasn't got a value. I mean, k here hasn't got a value, but you cannot refer to it in code because it's not declared yet. So every variable, when it is declared, has a value. And that's an advantage compared to having all variables declared at the beginning and either leaving them undefined or assigning everything to 0, which might not even be a good default, just in case they're referenced elsewhere in the code. Now, the other related feature is the ability to declare a variable within a block. The visibility of a variable declaring a block is the block itself. So here you cannot use j, or here, for example, you can also not use j. If you try, you get a compiler error because this is not visible in the location. This is a very simple example of type inference. In this case, I is an integer because this is a numeric type that fits within integer. Now, type inference becomes very nice when it's applied to larger and more complex data structures. And I have to remember here to free my dictionary because I showed that demo before and some people were puzzled about the lack of a free statement. And it should also have a try-finite block, to be honest. So here's a dictionary. Rather than having to declare to dictionary string integer and then using the variable, I just infer the type from the create construct. And similarly from the pair, which depends, this is a t pair string integer because that's what the dictionary is based on, but I don't have to further declare t pair string integer. The type is inferred from the context, in this case the dictionary type itself. And again, everything I've been showing for variables, actually most of what I've been showing for variables works for constants. You can assign a constant with an expression. And notice only that the syntax is the constant assignment syntax. Finally, when you have a for loop, you can have a local inline variable declaration for the loop variable itself. Again, with type inference, you don't need to explicitly declare the type. And what's nice is that at the end of the loop, outside of the loop, the variable I is not accessible anymore. In the past, you would get a warning indicating this could not have been the expected value and was not recommended to use a loop variable. Now it's an error because the variable is visible only within the loop itself. So as I'm trying to say, inline variables are not just syntax sugar. The fact that they have a specific scope, both in terms of the initial position you can refer to the variable and the final position, it's only within the block the variables are declared into, can really help improving code correctness. So don't see those just like syntax sugar, but see them as a way to change the lifetime and the visibility of a variable. Now I'm going to show you 3 more demos. One is there an effect on performance? Well, possibly there is some. If you don't declare a variable that you don't need to use, if that is managed, like a string, there is a slight effect on performance. I'm going to show you some extended type inference demos and also further details about the lifetime of a variable with block scope. So first thing, for performance, I have 2 versions of a function. In the old style code, the function has a local string. In some cases, that string is assigned and it's used in the algorithm. In some cases, it is not. in the rewritten code, the same variable, string variable, is local to the block, and so if we go to the other branch, it's not actually initialized and released or touched in any way. Now, this is very fast code, so to get something that reasonable, I have to go with 100 millions of execution, and that also highlights the fact that this is basically not even a perceivable difference in most scenarios. Okay, so let me run this with release mode and see what it takes for the execution of the old code versus what it takes for the execution of the new modified code. As you can see, the difference is 300 milliseconds out of 6,000, so it's a very, very limited difference. I mean, we could claim there is an advantage, but this is really in some corner cases, and it's most likely fairly limited. Now, there might be scenarios where having a local variable has, like a managed record or some other structures, has a net positive effect. But in most cases, it's not really relevant. Next demo I want to show is covering more ways to do of type inference. This is a very simple way of objects type inference. You can assign an existing object, sender, self, or button 1, and you can also create a new object and assign it to the variable, in which case you'll have to free it. Now, this is very straightforward, but just in case, let me show you what is the names of these three classes are. So it's tButton, sender, tStringList for tStringList, and pform15 for self. The other code snippet, which I'm not even going to run, is other more creative type of type inference. One is inferring the type of an anonymous method. So procedure 1 equals procedure, and the type is inferred. Inferring the value of a tNotify event, in this case assigning the button to onClick event, which is a tNotify event type. And in the last case is assigning an array of objects, sender, self, sender. Now, if you assign self and sender, you would get two t objects, because that's the minimum common denominator. And of course, there is no name. There is class name as an option. tform17. But if you cast sender to a component, then you'll get an array of components, and you can in fact use the name property of the component. So you can change the code in a way that it reflects the actual type that's inferred from the array. Of course, there might be scenarios where the objects in the array are, the types you pass to the array are not compatible, and in that case you will get an error. Last demo that I want to show also around inline variables is block scope. Look at this code snippet. I have begin and block, and within the block I declare a string list and a smart pointer. This is a modified version of the smart pointer code I showed before, and this modified version logs when the object is created and destroyed. The smart pointer itself, not the external object. So in this case, I'm just say, hey, I'm here, begin and block, and log there. Now, what is going to happen at the smart pointer record gets out of scope at the end statement, and at this point, it is cleaned up, and the internal string list is destroyed. So you get not just visibility of the variable within the block, but you also get lifetime within the block for managed types. Now, notice that, and this is a bit weird, that what I'm doing here is having a beginner block with no statement around it, which honestly was technically possible in the past in Object Pascal, but almost completely useless and rarely used. Now it becomes an option because it implies lifetime and visibility for this variable, which is limited and not in the scope of the entire method. So let me run this and see what happens. And here I have the here statement, smart pointer created, items 1. This is when I'm logging the items. Smart pointer destroyed at the end statement, and there, which is after the end of the block. So that's fairly interesting because it adds a new option in terms of lifetime for variables to the language. Other changes to the Object Pascal language are relevant, although I'm not going to demo all of them. Arc, automatic reference counting, has been removed from the Linux platform. We introduced it last year with support with Arc because we still were trying to plan to have Arc on all platforms eventually, but because of the VCL code compatibility with Arc would pose a huge challenge to existing third-party component vendors and existing users' code. And because we still want the unified model across all platforms rather than having two different memory management models, we've decided to revert back the plan and phase out Arc, although that's going to happen in steps. So we plan to phase it out of the language completely, including mobile in 10.4, but for now we've made Linux platform 100% compatible in terms of memory management with the Windows platform. There was also a performance penalty that we evaluated and possibly ways to work around it, but that would have been a very significant effort. There's a side effect that we moved next-gen style from Linux is that you can technically use ANSI strings, but do that with care because the string mapping in terms of the control characters and others is different from Windows and you can get into some trouble. There are also new warnings for undefined attributes. That's something I like and I'm going to show in a second. There are changes to the way 8-byte data structures are passed as parameter for C++ compatibility, and also a lot of quality fixes and optimizations in the foreign loops. The only thing I want to demo here is what happens when you have an attribute that is not defined, and so you get an error. Now in the past you would get undefined defined language feature, custom attribute. Now you get unknown custom attribute, which is a much more relevant error message. If you want this to become an error, you can turn on this warning. Each warning can be turned into an error. So with warn unknown custom attribute error, you can turn this into an error, which probably should be the case because if you have an attribute, it needs to be defined somewhere. And so now if we compile, we get an error message that the custom attribute at this line is unknown. So it's a small thing, but it's something I like because I was a bit annoyed by this unsupported language feature when the error actually was using an attribute that was not defined in the code. So this is what we've done. In 10.3, we also worked quite a bit on manage records. That is the ability to have a parameter that is create and a destroy destructor for record, and also some copy operations. But eventually we found it wasn't stable enough and it was causing some compatibility issues with existing code. So we've disabled it in the final version and it's not part of 10.3. But of course, that's the first thing we're going to work on for the next major release of the Delphi language, along with other features that were already in the works and we're continuing working on, which are nullable types and a few more syntax enhancements. what we are planning also for the next year around the Delphi language is adding support for 2 additional 64-bit platforms, macOS and Android. No promise for the time frame, but this is something that we are actively planning and working on. So the Delphi language has a long history, continues to evolve, and has a bright future. It's heavily used today, and it has a lot of power and capabilities that are not that commonly found on many other languages. It's a great modern multi-platform language. It offers fast compile time, great runtime performance, a wonderful ROD model with a powerful object-oriented language behind the scenes. 20 years that have been invested in expanding the language and growing it, and we plan continuing for the foreseeable future. Thanks a lot. Here's again my contact information, my email, Twitter account, and blog, and also I'm going to post the code for this session under my Delphi Sessions GitHub project. And now let's open it up for questions.